Okay, next problem. We want light. There's a light source, and it's radiating outwards in all directions spherically at radius 2.1 meters. Intensity is 0.84 watts per meter squared. Using this information, and we have a bunch of recalls, the constants we deal with. What is ERMS? That's part A. We have a formula. Intensity is going to equal to 1 over C epsilon, or excuse me, C mu 0 ERMS squared. And let's go, all we have to do is invert it. ERMS. And that RMS stands for root mean square root of intensity times the speed of light times mu 0. I will be back right after calculations. I get 17.8, and that would be volts per meter or newtons per coulomb. Doesn't matter. Now, I'm a little concerned about my units. So the units of intensity are power per meter squared, which is joules per meter squared second. That's intensity, times speed of light is meters per second, times mu 0 is a Tesla meter per amp. And so the meters squared all cancel out. This is a joule. Let's break Teslas down. A Tesla, joule, Tesla per, well, a second times an ampere is a coulomb. So second times amps is the coulomb. So we'll have joule Tesla on the top. Well, a Tesla is equal to joules, and that would be, a Tesla would be a Newton. Seconds, coulombs come down. A Tesla would be a Newton per amp, and that would be meter. So a coulomb, okay, seconds times amps would give us a coulomb squared. So seconds times amps gives us a coulomb squared. And I'm going to express joules as a Newton meter. Newton, so on top it's Newton squared meter over coulomb squared meter. Meters cancel. Take the square root of this stuff and you've got newtons per coulomb or volts per meter. Okay, so I'm convinced about my units and I'm convinced about my number. B, well, this is real easy. B RMS just equals E RMS over the speed of light. Just take my previous answer and divide it by 3 times 10 to the 8th. And I get 5.93 times 10 to the negative 8 Teslas. Okay, let's see. And double checking units again. Before we said a Tesla was a Newton per amp meter. So that should equal ERMS, which is Newton per Coulomb, is electric field times meter. That's reciprocal speed of light. So everything works out. Coulomb per second is an amp. Here's the meter. Here's the newtons. Everything's cool. So I'm convinced of my units. I'm convinced of my numbers in both cases. C, light pressure for complete reflection. That's very simply the intensity over the speed of light. Excuse me, reflection, twice the intensity over the speed of light. Now, 2 times 0.84 divided by, anyway, you get the picture. I get 5.6 times 10 to the negative 9. Pascals. So that would be intensity watts per meter squared. Anyway, watts per meter squared. You would have newtons per. Eventually, you'd wind up with newtons per meter squared. Okay, and that's the dimensions are pretty easy to prove on this one. D. Now, that's for reflection. You're going to get twice as much pressure. Pressure, if it's totally absorbed, is just going to be half this quantity. Okay. Now, in the previous problems, you can tell why I pause a second to do these calculations, because I didn't on this problem, and you can hear me clicking my calculator in the background there. So, E, intensity at 5 meters. Now, this is pressure, not power. I'll put PR for pressure, PR for pressure. Intensity is going to equal to the power over 4 pi r squared. So the intensity at R2, intensity 2, is going to equal to intensity 1 times R1 squared. So R squared, in this case, we don't have any subscripts on it. We don't have I1 and R1. So we just have I and R right there. But if we change our distances, now we're changing to from 2.1 to 5 meters. So we expect intensity to go down by the 1 over R squared law. And sure enough, anyway, there's the formula. .84 times parentheses 2.1 divided by 5, close the parentheses, square away, and hit the equal sign. 0.148 watts per meter squared. 148? Yes, 148. All done. Okay, that's it for 32 to 36. Have good luck on the exam. Study these examples. Remember, there are variations. I'll throw in curveballs. I might go to a shorter distance, a longer distance, and so forth. I'll change things around in these problems. The problems will be similar, but not exact. And everybody needs to understand that. Okay, but these give you good review examples. Have a good luck on your exam.